surprise, happy birthday, okay? I just made you guys a checklist on carboxylic acids and esters. I'm gonna make a checklist for all of the topics I will post on this channel. Also acylation should do later on. But yeah. And obviously there's red, amber and green. If it's red, you go back and focus on that topic. And then there's a tick if you cover the topic. If it's amber, you need to go back to it again. If it's green, perfect. Okay, so that's all. This started, guys. Okay, let's learn more about carboxylic acids. Okay, so carboxylic acids are weak acids. This is because they partially dissociate hydrogen ions. Okay, meaning that they only produce few hydrogen ions, but they produce enough hydrogen ions to react with carbonate, such as sodium carbonate, to produce carbon dioxide. And we'll show that later on in the video. And I'm going to show you how this happens. Not the carbonate bit, but how they partially dissociate hydrogen ions. So as you can see on this side, we have a carboxylic acid, right? And then the bond breaks between the oxygen and the hydrogen, okay? And when this bond breaks, the electrons are pulled towards the oxygen. Right, they're pulling towards the oxygen. Because of this, the hydrogen ion is then released, right, within an equilibrium reaction we can see here, and it produces a carboxylic ion. So the oxygen becomes negatively charged because it lost the hydrogen, right, which means it produces fewer hydrogen ions. So that's how they partially dissociate. Okay, so we covered that now, but let's look at the melting and boiling points. So we see here there are two carboxylic acids shown. So here's the carboxylic acid with a double bond O and the hydroxy group, so the OH, okay? So there is a hydrogen bond between these carboxylic acids, because here you can hear that the oxygen is attracted to the hydrogen attracted to the oxygen, there's hydrogen bonds, okay? So there's two hydrogen bonds between the two molecules. This means the melting and the boiling points are higher than equivalent alcohols, and I'm going to say why. So they are higher than equivalent alcohols because they are strongly attracted to each other, okay? So the carboxylic acid molecules are more strongly attracted to each other than alcohols, as alcohols can only form one hydrogen bond. This is because they only have one OH group. They don't have another oxygen, no other OH groups. They only have one. Whereas carboxylic acids, they have an oxygen and an OH group, okay? Strong attraction, strong van der Waals forces, you know, guys, okay? Not van der Waals, sorry. Strong hydrogen bonds, okay, guys, between the molecules. Linked to, you know, year 1 content. Must revise. Okay, so we counted that. Now we're gonna look at carboxylic acid solubility in water, okay? So you can see I drew here a water molecule and a carboxylic acid, okay? So obviously there's gonna be a hydrogen bond. Yeah, you guys knew that? Yeah, okay, that's good. Okay, I hope you did. So there's a hydrogen bond between the hydrogen and the oxygen. As you can see here, there's two lone pairs. Well, that's how you actually draw it. You know, hydrogen bond. Yeah, you know how to do that. Yeah, okay. And there's a hydrogen bond between the carboxylic acid and water. So therefore, it's soluble and easily dissolved in water, okay? So there's a hydrogen bond between acid and water. It's soluble. It's soluble and easily dissolves in water, okay? And here I drew an example. So there's a carboxylic acid group at the end, and it's attached to a long carbon chain that's juicy and spicy, okay? A long carbon chain, guys, okay? And that long carbon chain is a non-polar head. So this is non-polar because it doesn't, well, I assume only has carbon and hydrogen bonds in it. But the carboxylic acid group has some electronegativity going on with so therefore it's polar, okay? We know that from bonding. So the longer the length of the R group, which is the non-polar head, so the longer that chain, the more insoluble it is in water, the more insoluble the carboxylic acid is in water. Okay, so let's get into this now, okay? So obviously this is not my favorite part, but like we're almost dead to the mechanism, okay? So, okay, so this is what I was saying in the first slide when I was talking about weak acids, right? So, as I was saying before, carboxylic acids, they partially dissociate hydrogen ions, so they produce fewer ions, but they have enough hydrogen ions to react with carbonates. So here, I drew ethanoic acid reacting with sodium carbonate, Na2CO3. Guys, remember your ions, yeah? Your ion charge tables, okay? So this would produce sodium ethanoate, okay? So sodium ethanoate. And here you can see I did not draw a bond between the oxygen and the sodium. Why is that? Because it's not covalent. Don't be stupid. It's not covalent. It's ionic, guys. It's ionic. Ionic. Negative and plus. Sodium is a solid. It is not a non... Wait. It's not a solid, sorry. Sodium is not a metal. It's not... Wait, what? No, sodium is a metal. Sorry. Sodium is a metal, guys, okay? That means ionic bond, you know? Sodium... I mean, not... Metal with the non-metal, guys. It's ionic. Let's get... Okay, it's ionic, okay, guys? Don't... Remember that. And obviously, if you know how to name esters, like in the last video you watched, it'd be sodium ethanoate because there's 2 carbons here. That's the O8 group. Remember, C-double-bond-O, sodium ethanoate. Okay. And then it produces water and carbon dioxide. You need to remember that because that might show up in the exam. So, oh yeah, and carbon dioxide is fizzing. You know, testing for carbon dioxide is fizzing. Okay. And then here we go. So methanoic acid, not ethanoic acid, again reacting with sodium, just sodium solid, okay? Remember, sodium is a group 1 metal. What did we learn from group 1 metals? When they reacted, they produce hydrogen gas, okay? So here it produced the same product and it produces hydrogen gas because it's just sodium, okay? So the test for carboxylic acid is you add sodium hydrogen carbonate. So to test for carboxylic acid, sodium hydrogen carbonate, which produces water and carbon dioxide, and the same product with the sodium ethanoate, sodium propionate, sodium methanoate, whatever it is, okay? Sodium hydrogen carbonate to test for carboxylic acid. Right, now we're going into the juicy stuff, okay? This is probably my favorite part, I'm not gonna lie, because it's kind of straightforward, so... Okay, so esterification. Wow, what could esterification... Of course, guys, of course esterification means you're making an ester. Guys, okay? So, esterification is the process of a carboxylic acid reacting with an alcohol, right? Okay, alcohol, drunkie, okay? Carboxylic acid plus an alcohol creates an ester and water. And it's within an equilibrium reaction. And I'll go through that later. So yeah, there's reaction with alcohol. So the reagent is alcohol because that's what you react it with. That's what a reagent is. You react it with an alcohol. So you react a carboxylic acid with an alcohol. Could be any. Primary, secondary, tertiary, alcohol, whatever. And then the conditions for esterification is concentrated sulfuric acid and it has to be warm. Okay? Concentrated H2SO4 and it's warm, okay? So yeah, so over here, these 2 arrows mean it's in equilibrium, and because of this, each side has to reach equal reactants, equal products, which means it does not give good yield. You cannot get more than the yield you have because it's equal, right? Because there's not good yield, it's equal yield, you can't get more, and because it's at equilibrium. And esterification happens because there's an elimination of water. Water gets eliminated. That's why water is produced in the products, okay? So water gets eliminated. Therefore, the group from the alcohol attaches to the carbon there. And yeah, produces the water. Okay, guys. So I want you to draw these out if you need to, but it'll be better to draw it out. And I want you to name the products after you reacted in these equations, okay? I want you to write out the products of these. You can pause and play the video when you finish. Okay guys, if you got these all right, Well done, okay, well done. You're just a few steps further from getting your A stars, okay, because they give these questions probably once every paper. So yeah, so ethyl propionate, ethyl ethanoate, propyl 2 methyl propionate. It's all about, you know, nomenclature. If you're not good at naming, go back to nomenclature, okay, because that's like your basics. If you fail, you fail. Okay, and esters, so esters are sweet. That's also you need to know that. Esters are sweet and they are used in perfume, food flavorings, yeah, looking good, okay. And then they're using acetone, so nail polish remover, nail polish, her nails are tea, and washing liquids. So guys, that is it from me. I hope this video helped with your revision. Do lots of exam questions. I usually go on Access Tuition, PMT. Sorry it cut off randomly. I forgot to record. But yeah, PMT, you know, secret websites on the internet for your questions, you know, like questions your teachers give you. That's really good as well. But yeah, bye guys.